So after the first couple of videos, you might be saying to yourself, wait a minute, this isn't the course I'm taking. In my course, we're studying how to solve systems of linear equations like this one. And this guy's talking about decomposition. Also, if you're a math major or a physics major or maybe a computer science major, you're taking this approach to linear algebra, where the subject starts with a bunch of axioms. And then from there, you proceed to theorems and proofs. All I can say about this approach is that perhaps it's not the subject itself, but its formalization. And it'll be to a certain extent up to you to learn and figure out the subject itself behind its formalization. So going back to the majority of students who start with linear systems, my point is that linear systems are a problem in decomposition. When we get to linear systems soon enough, we will rewrite them in the form that will make it look like a problem in decomposition, which is what it is. We will rewrite this system in this form. Now, I don't yet expect you to understand what this form means, but you should really recognize that it's very similar to the problem of mixing Bach with MLK that we just considered in the previous video, which looked like this. We took a certain amount of Bach, it was 0.5, so a little bit less of Bach, with a little bit more of MLK. This number was 1.5. So we took 0.5 of Bach with 1.5 of MLK, and then we played that sound. And it was the sound that went into your ear. And by just listening to the sound, you were able to tell that, yes, there is a little bit less of Bach, and yes, there is a little bit more of MLK. So your ear solved a decomposition problem. Now, a linear system of equations has the same overall form, where the right-hand side is known, and your job is to determine in what proportions the objects that appear on the left-hand side need to be combined or added so as to produce the right-hand side. So once again, linear systems are a problem in decomposition. So by the time we get to linear systems and recognize them as problems in decomposition, you will already know exactly what the solution looks like. And the only thing left to do will be to determine the numbers that go in the answer, which is easy to do. But I promise you this, when you're presented with this very system, you will be able to immediately come up with an expression that captures all of its solutions, and you won't have to use any algebra or arithmetic to come up with that expression. So I would like for you to take a look at the system now and remember the feeling of looking at a linear system and not immediately knowing all of its solutions. Because soon enough, when you look at a simple system like this one, you will immediately know all of its solutions. And it will be very interesting to think back to this moment and realize how much you've learned. So let's spend a little bit more time talking about decomposition and talking about the general types of objects that linear algebra is able to study.